Cool. So for number 9, the trick is to have a look at the number of carbons, and you'll notice that there's 8 over here, and you'll notice that there's only 1 over here. So if you were just going to play with this trial and error, what number would you put in front of the CO2?
8.
Correct. So let's guess if it's 8 and see if it works later. So that balances the carbons. And then if you look at the hydrogens, that's the second thing you can have a look at. The hydrogens there are 18 and the hydrogens there are 2. So there's 18 in the first molecule and there's 2 in the second one. So what can I multiply the waters by to get to 18?
9.
Correct, so I can put a 9 there. And that sort of takes care of the carbon and the hydrogen. Now you have to sort out the oxygen, and that's the tricky one because it appears in both the chemicals. Yeah. So if you sort out the oxygens, we have that oxygen there. Ooh, hang on, that's a bit big. We have that oxygen there, and we have that oxygen there. So with your 8 times 2 is?
16.
Correct. So for oxygens, you have 8 times 2 plus 9 times 1.
9. Yeah.
Ooh, and that gives you 16 plus 9 is? 16 plus 9
25.
25, correct. In other words, you need some number here, x, to multiply by 2. And you have to say that 2 times x is going to give you 25. Am I right?
Yes. And the problem was I know what x could be.
Correct.
But I was not sure if you could put a decimal in there.
Okay. You can. There's nothing wrong with it. It just doesn't look as nice as putting a whole number. So you are absolutely allowed to put 12 and a half there. So is that what you got to at the end?
Yeah, I got it right then.
Cool. So if you got to that, that's good. But for the guys at home, the 12 and a half is perfectly acceptable. Now, what could you do to everything? In other words, every single number to get rid of the 12 and a half. Think of it like maths. Like if you had everything as halves and quarters and fractions, and if you wanted everything as a whole number, what could you do?
I don't know. Would you round it up? Or?
So rounding is one thing, but let's say that, let's give you an example just with numbers.
So can you round it off? Because I've never really heard of like rounding off the numbers.
No, never round off. No, never round off, never round off. No. Okay, so I'm going to give you a ratio, and I'm going to say that the ratio is 1 to a half. Can you turn that into a whole number ratio? So in other words,
I'm pretty sure you can.
You can. So what would you do to turn it into a whole number ratio? What is 1 to a half, the same as in terms of whole numbers?
2 to 1.
Correct. There you go. 2 to 1.
Yeah.
There you go. And what did you do to the half to get it to become a 1?
Multiplied by 2.
Correct. So now have a look over here. I'm just going to quickly highlight this for you. What can you, not that highlighter. What can you do to everything over here to make the one that is a half into a whole? So same as what you did in the top right-hand corner. I'll remind you what you did here. Just remember what you did there in the top right.
So we want to change 12 and a half into a whole.
Exactly. So what would you do to that to get it to a whole number? So if you multiply anything that has a half in it with by 2, would you agree with me that you'll get a whole number?
Yeah, so that means you have to multiply it by 2.
Correct. So multiply everything by 2.
Yeah.
So what you could do, everything, and then you can multiply everything by 2. So you could end up with 2 of these. 25 of those. How much was the carbon dioxide? That will be 16, and the water will be 18.
18.
If I'm not mistaken. And that should work out like that. I very much doubt you'll get a one as difficult as that in a test or an exam. I think that's probably as difficult as that could get. Cool. But in reality, when you get to
Yeah.
A level, if you carry on with chemistry, you could have left it with the half. You don't even need to multiply it out to get the whole numbers. The half would have been fine.
So
Cool. So besides that one, were there any other problems?
no, not really.
Cool. Pretty straightforward. It's just
I
some.
just wanted to make sure that we can leave the decimal.
You can, yeah, you can leave the 12.5. But if they ask, for example, if the question says, I don't think it will, but if they say something like, just going to write this for you quickly. If they write whole numbers, then you have to get it correct. So just be careful. I doubt they will, but you never know. So I honestly don't see very many of these questions coming up in your papers. So it's difficult to even find past papers to find examples. Cool. So if that's the only question you had, then I think that's basically it.
Yes, sir.
Cool. Unless you have any other questions,
Yeah.
you're more than welcome. I mean, I've got another 20 minutes, so I'm free to help you with anything.
No, I understand
Yeah,
everything.
I don't.
You good?
Yeah, also.
Good. Okay, so I'll go through a couple of worked examples and then I'll just post it for the guys on YouTube.
Okay.
Cool. Cheers, guys.
Bye, sir.
Bye, guys. Be
Thank
good.
you,
Bye,
sir.
sir.
No problem. Anytime. Thank you for joining.